Welcome back. Let's do question 2a. Given f of x is equal to 3 sine x minus 45 degrees and g of x is equal to 2, determine correct one decimal place the values of x, where x it should be between from negative 45 degrees to 360 degrees. So those 2 points are included. So satisfying f of x is equal to g of x. So what does this mean? Okay, we want the points where the two graphs are equal. So it means we want the points of intersection here. Okay, the points of intersection there. So how do we do that? How do we do that? So we are saying this is where f of x is equal to g of x. I want to remind you about the general solution for sine of an angle. Right, let's say we have sine theta is equal to m. Right, the general solution for this will be theta is equal to the reference angle plus 360 degrees times k. So let me just say times dot k here, times k, where k is an integer, right? And then, or you can say that theta, okay, or there are two solutions, solution 1 and solution 2. So, or theta is equal to 180 degrees minus reference angle, okay, plus 360 degrees times k, where k is an integer. You see that? Okay, so these are the general solutions. It should be like that. So let's just do that. So we're going to have solution 1 and solution 2. Right, so we have this f of x is equal to g of x, so meaning that 3 sine x minus 45 degrees is equal to 2. And then what do we do here? We have to isolate this part. Okay, we have to isolate this part. So we divide by 3 on both sides of the equation. We have sine x minus 45 degrees is equal to 2 over 3. Right, and then let's get our reference angle. So this whole bracket is your angle. Okay, so angle x minus 45 degrees is equal to arcsine 2 over 3, the inverse of sine. And then x minus 45 degrees is equal to 41,8 degrees. Okay, they said one decimal place. So now we're going to have solution 1. We're going to use this, and then solution 2 this. So let's have solution 1. Okay, so it's going to be our reference angle. This means this one here is going to be x minus 45 degrees, and then the reference angle is 41,8 degrees. So it's 41,8 degrees, which is the reference angle here. Then plus 360 degrees times k. Okay, where k is an integer. Right, that is solution 1. Okay, let's simplify this. So we transpose negative 45 degrees, so it becomes x is equal to 41,8 degrees plus 45 degrees plus 360 degrees times k, where k is an integer. And then this is 86,8. It's going to be 86,8. So x is equal to 86,8 degrees plus 360 degrees times k. And then you see that. So now this is the first solution, general solution. But remember, we want the angles between, or from, not between, from negative 45 degrees to 360 degrees. So we're going to use our calculator for that. I'm going to show you. Right, let's have the equation for solution 2, the general solution for solution 2, solution 2, ION. Okay, right, so solution 2 is going to be x minus 45 degrees is equal to 180 degrees and minus 41.8 degrees. I'm using this one here, okay, and then plus 360 degrees times k, where k is an element of real numbers. You see that? Okay, again, we can transpose this and bring it this side. So if you say 180 degrees minus 41.8 degrees plus 45 degrees, you're going to get 183.2 degrees. So it means x is equal to 183.2 degrees, then plus 360 degrees times k, where k is an element of real numbers. Okay, so this is for solution, general solution for what? For solution 2. Right, and then from here, we are going to use our calculator. Let me take you to the calculator part. Right, let me show you how to use your calculator to get your solutions. So let's start with solution 1. So what you do, you go to your mode there. Remember, the calculators may be different, okay? So you press mode, and then you go to table. You find that in your calculator, table may be number 3. You see that? So you press 3, but here in this calculator, it is 7. So you press 7, you see that? And then you can enter your first function, which is 86.8 plus 360 times k. So k is our x there. So we're going to say 86.8 plus 360 then times k. So we're going to put this x here. So we say alpha, you press alpha, then alpha x there. You see that? Okay, that is the first function. And then press equal sign so that you can get the next function. Then we get our second function, which is 183.2, 183, okay, comma 2, then plus 360, 360 times, then you press alpha, and then you put your x there, which is going to be your input value, x, okay, right, and then you press equal sign. So start, you can maybe say from -1 to 2 is fine, or -2 to 2. Let me start with -1, okay, and then and let's say 2. Then step, it has to count in ones because it's from -1, 0, 1, 2. It's counting the integers like that. Remember, k is what? Is an integer. So it can be -1, 0, 1, 2. So your step should be 1 there. And then you press equal sign. And then you can choose the angles that you want according to the domain that you're given. Like there they said from -45 to 180 or 360, but it's fine. According to the domain, it means these are the angles that we want. So it's 86.8 degrees and 183.2 degrees. You can even check the other angles, but they are not what we want. We want angles within the domain that we're given. So these are the two angles here. Okay, I really hope this assisted you. We managed to use our calculator, and then we managed to get that our answers are x is equal to 86.8 degrees and then 183.2 degrees. Okay, then that's the answer there. So we're done. And then so it means these points, these values that we got are the intercepts, the x coordinates of what? Of the points of intersection. That's where the graphs intercept. That's where the graphs meet. We see that. So these are the points of the x coordinates of the points of intersection of the two graphs. Okay, so we're going to meet when we do question 2C.